Hey everybody, I wanted to review a little bit of the lecture stuff that we did in class and actually go over the homework that's due tomorrow for those of you that are in A and D period. For those of you that are in E period, the homework's going to be due Tuesday. And I actually like the idea of going over the homework before it's due. I definitely want you to give me the time on the homework. My ideal is not that you wait for the video to begin solving, but that you actually attempt it on your own and then use the video to help you figure out areas where you're stuck. If you're just relying on me to do these problems for you, that's not going to be good for your grade. And as a teacher, of course, my ideal is not just the grades, but the learning. And I can tell you my experience is you've really got to be willing to wrestle with the material to really have it settle and make sense. So we're dropping a ball from 2 meters high, and we want to know its speed right before it hits the ground. And in class, what we actually said is that the mass of this ball is going to be m equals 0.03 kilograms. And what we want to do is basically use conservation of energy to get the speed right before it hits the ground. And we also assume that no energy is dissipated. And we had formulas that were given in the last set of notes, which was Eg equals mgh, and Ek, which is kinetic energy, moving energy, is 1/2 times m times v squared, like that. So using conservation of energy is pretty straightforward once you know the energy bar graphs, which is what you practiced in your first homework, and the videos are available on Haiku. So we start off with all gravitational energy, and the reason we know this is that there's no spring, so we don't need to worry about that. And we also know that it started from rest. I actually told you that in class. So V equaling 0 actually means that we have absolutely no kinetic energy to worry about at all. We were told that there was no dissipated energy at the end. That's something that we'll tell you. There's no spring energy happening here. And then the gravity energy is all but gone because we're almost touching the ground. So what that means is all of this gravitational energy is now stored as kinetic energy, so to speak, in the motion of the ball. So what we basically have here is Eg, and I'm going to type a big old equal sign right here, equals Ek. Now, I asked you a few questions here just to kind of make sure you understood what was going on. So is the ball moving right before it hits the ground? Yes, it is. It absolutely is. Does it have any measurable height the instant before it hits the ground? The answer to that is actually no, it doesn't. That was something we stipulated in the problem. It is almost on the ground. Now, based on these two facts, we really do have it that our equation here is consistent with the graph. Now what we want to do is we want to determine the gravitational energy using the formula. So we have Eg equals m times g times h, which is going to be 0.03 times 10 for gravity, which is the gravitational strength, which is 10, and then the height, which is 2 meters. And when we simplify that out, we're going to get 0.6. And the unit for energy that we use in class is joules. You might have heard that in chemistry. So just energy unit is joules, just a heads up. Now, what is the kinetic energy of the ball right before it hits the ground, and how do we know? Well, look at this equation here. This equation, kinetic energy, is actually equal to the gravitational energy. That's not a formula I'm going to give you. You got to be clear on how we do this. You have to know how to set up your bar graphs based on looking at the situation, and you have to be able to write down that equation. So that's not an equation you can really memorize and hope that it's just going to magically work, okay? So what's the energy right before it hits the ground? The kinetic energy is 0.6 joules because of the bar graphs and conservation of energy. That's this principle. Okay. Now, once we actually have the 0.6 joules, what we're going to do is we're going to actually use the kinetic energy formula to get the speed. So that means here EK equals 1/2 mv squared. I'm just using that kind of calculator typing it. So 0.6 equals 1/2 times 0.03 times v squared. And when we actually solve for v, you're going to get that it's 6.3 meters per second. All right, so what I'm going to do in the next video is I'm actually going to jump straight to the homework that we had. And the reason is that I know that we did another worksheet in class where we graphed force versus height for gravity. Some of you may remember that. I want to actually go over that in class when we meet next time. So this is the speed, and I hope this video was helpful.